Hi, this is gonna be the example for solving 2D equilibrium. So let's take a look. So there are two forces, P and Q, applied showing to aircraft connection, and knowing the connection is at equilibrium, when they tell us that, which means it's static, right? If it's static, we know sum of all the forces is gonna be equal to 0. And this is two-dimensional. So which means there are x direction and y direction. So that means those are the two equations we have. All the x components of all the forces add together equal to 0, same wise for y. Then they give us P and Q magnitude. This is said we can label right here, 500 pound, and Q is 650 pound. And determine the magnitude of forces acting on the rods A and B. So our first step is going to be our FBD diagram. So FBD diagram is all the forces acting on this object. So this is this connection. And we're going to consider that's going to be where all the forces acting on. That's where the force applied on. Then we'll have, notice all those four forces here going through this same red point. And let's label all the forces here. We have force P, 500 pounds. Then we have Q going this direction, 40 degrees from vertical direction, 650. Then we also have this force A acting on the rods. And we also have this force B. It's going this direction. So arrow going that direction, that's going to be our force B. Okay, so you could also potentially, what I normally like to do is actually go ahead, draw FB that direction. So all the forces going through this red point. So I basically move that FB, translated to this point, and that's our FB. I didn't do any change. Why? Because FB is going to be in horizontal direction, so it is in horizontal direction, and the magnitude of force is determined on the length of this arrow, so I can do that. And then the two unknowns, they said determine the magnitude of force at A and B, so we are solving FA and FB. Two unknowns. So you notice for this problem, there are two unknowns, and they are FA and FB. And in order to solve two unknowns, we need two equations. And do we have two equations? Yes, we do. Forces at x equal to 0 and force at y equal to 0. That is how we solve this 2D equilibrium. So in essence, 2D equilibrium is two equations, and they are forces at x and forces at y, both equal to 0. Then we can solve your two unknowns. That's it. So now let's solve this problem. Let's look at there are how many forces? 4 forces, right? And which is labeled in the green line here. Now, what we're going to do is we can still using our training wheel, which is that table that help us. But later on, when you get more fluent, you don't need to list up this table anymore. You can read off this training wheel. But as right now, we're going to continue using that. What we're going to do is we're going to list all those 4 forces, FA, FB, and force P, and force Q, right? And all those actually, I'm going to put a hat on. Why? Because they have direction, right? It's a force, it's a vector. And then we're going to decompose each one to X component and Y component. So now let's take a look. Let's look at FA first. FA is this force right here. We're going to decompose to X direction and Y direction. So we can isolate that, FA. When we decompose, we'll have x component. We're going to use rectangular. So we get FA x, and this is our FA y. Remember, we have to consider sign very clearly. This x component is pulling to the left, so will be negative. So this angle here is 50 degrees, and this x component is adjacent to 50 degrees, so we'll be using cosine. So we use FA times cosine 50, and it's negative direction. Since we don't know, we're solving FA, so we just write down this variable. Now so I hope you know how to figure out the y component. So pause a second, write it down yourself. Okay. So I hope you have FA times sine 50, because it's opposite to the angle, so it's sine, and it's upward, so it's positive. It's FA times sine 50. Now, do the same thing for FB. Now, let's look at FB. FB is a unique scenario. Why so? It's perfect x direction and positive x direction. So the x component will be what? Will be just FB, because you're solving that. All the FB forces is on x component, FB. Then how about y component? Nothing on y. So it's 0 since it's perfect horizontal. Okay. Now let's look at the P, the force P going downward. And again, pause for a second, see what you wrote here. What's x component of P? Will be 0. And how about y component? It's going straight down. All of them going straight downward. Downward is negative, and it's negative 500 because we already know the magnitude, 500. Now the last force is Q. Q is 650 right here. And if we were trying to isolate that out, so Q is right here, it's 650. And we are going to decompose that x component and y component. And this angle here is 40 degrees Celsius. So what's going to be the x component? So x component is going to be opposite to 40 degrees. So that will be sine, so it's 650, hypotenuse times sine 40. And it's going to the right, so that's positive. Now let's look at y direction. Y direction is this one right here, and it's adjacent to 40, so that would be negative, would be cosine. And it's going downward, so that would be negative. So we have all those four forces decomposed. Then, what's next step? So far, it's very similar to the 2D resultant, right? The idea is the same. Now we're going to add all of them together. We're going to sum up all of them. That will give us sum of fx. But now, since we are looking at equilibrium, we know this have to equal to 0. Same thing here. If we were trying to sum up all the y direction right here, that's all the forces y component add together have to be equal to 0. Then we'll have this one right here. So now the third step is basically construct your equations. So let's do that. We'll have our x direction equation, basically sum of fx equal to 0. Sum of fx, what do we have? Negative fa cosine 50 for the first term, then plus fb plus 0, then plus 650 times sine 40. That gives us 0. That's our first equation. Then we're going to do the same thing for y direction. Sum of all the forces at y will have FA sine 50 plus 0 minus 500 minus 650 cosine 40. That gives us equal to 0. Two equations, right? That's what we have. And two unknowns, FA and FB. Then we can solve this. In order to do this one, you have to simplify it. This you can use different ways. There are many ways to solve those equations. You can use your calculator, or you can use Excel, or you can use pen and paper. But here I want you to see, I want you to think forward, because right now you are in 2D equilibrium. You only have two equations. Later on, remember, we're going to have 6 equations, because we're going to have forces at x, y, z, and also we're going to have moment at x, y, z. They all have to equal to 0, because there's no translation, movement, or rotational movement. So how do we solve 6 equations by pen and paper, which is very tedious, right? So you got to find a tool. So this is very important. You got to have a tool for solving linear equations or systematic equations or system equations. How do we do so? Like I said, there are many ways. You could go looking at your calculator. Everybody has a different calculator. So if you do that, I would suggest you to do a YouTube video on solving linear equations using that particular model you have. If you have a Texas Instrument particular graphic calculator, put it in there, then go through that. Likely you will, just give you a heads up, likely you will create your matrix and then use RREF operation to do that. And or you can use Excel. If you want to use Excel to do that, you can. So do another YouTube video on that. Or for the rest of the course, I plan to use an online algebra calculator, just so you can see my screen. And that would work for you as well. Okay? So those are different approaches. So go make sure you have your own tool and you have to master that tool. Okay, so now I'm going to see if we can solve this problem using this online calculator. So now I'm going to take you to this website called wolframalpha.com. So take a note and bookmark it. If this is a tool you plan to use, wolframalpha.com. For this particular problem, you can certainly try to calculate by pencil and paper, because from equation 2, you can find FA, and then substitute FA to equation 1, you can find FB. But now, however, we're going to start using these tools. So now you're on here, you're going to have 2 equations. So let's go ahead and plug it to know how to write it in. So for example, this one is cosine 50 degree parenthesis 50 degree and FA. So let me see if I put FA there. Maybe just try A, then plus B, then plus 0. We can get rid of that. Then plus 650 times sine 40 degree. That gives us equal to 0. That's our first equation. And let's separate the second equation, with the first one is a comma. The second one will have A, because that's simple variable for FA, times sine 50. Then plus 0. Then we minus 500. Then we minus 650. Then times cosine 40 degree. Then that gives us equal to 0. So we have 2 equations, and I'm click on enter. So what? How do they interpret my input here? Now let's look at this. Is the input. Is this what I wanted? Cosine 50 degree. That's good, because I don't want to use radians. I want to use 50 degree. A plus B 650 times sine 40, and then you realize this is wrong. This is, they consider A times sine. That's considered inverse sine. So I'm glad we're looking at it here. So to fix that, I can quickly just switch the position, right? Do that. the minus 500. So the rest is the same, and then click on that. After refresh, what do we see? Well, this has been changed to sine 50 times A. That's good. And another thing I want to play with, actually, I'm going to do this as FA and change that as FB. See if they consider that as one variable. Just curious. Okay, they are confused with that because they think F is a variable, A is a variable. So in that situation, just use one letter. So just A. Okay. All right, so let's try that. Okay, so I think we got it. This is the equation we have, those two equations, and this is the results they have, right? Exact. And if you don't have the solution, if you have a solution that's in a different format, like for example, you might have a solution in exact format, you can change that to approximate form. That will give us the right. So in that situation, our answer for this problem, I'm just going to take a quick picture. I'll go back to my note. So in that situation, my FA, that's going to be equal to 1302.7, and the unit, whether in the unit of pound, so pound. And our FB is going to be equal to 419.55 pounds. All right, so that's the two unknowns. Those are the two forces acting on this aircraft connection, and you just solved. So quick summary, 2D equilibrium, two equations, two unknowns, and you decompose first after you did FBD diagram and solve those two equations. And now you have some tool there, either using this online, I'm going to make a note, this is Wolfram Alpha calculator, or your own calculator Excel to figure out how to solve those equations. All right, I'll see you next one. Bye.